Hello everyone, this is Dr. Esperanza, and if this is your first time to see my channel, I show videos of mathematics from algebra up until calculus, and for this particular series of videos I'm creating, I'll be giving a workshop on lessons from linear equation all the way to differential equations. So stick around and be with my students, and I'm going to give you a workshop on solving quadratics. That's why we have the third method. If it's not factorable, we can use completing the square method. I know it sounds complicated, but it's actually really simple. So you better stick around until the last one so that you would know the methods to use to solve for the quadratic equation. Do you know how to solve quadratic equation by graphing now? Or have an idea on how to solve it using graphing? Yes. Factoring? Yes. Completing the square? Of course not. That's why I'm introducing it. Okay, so how do you complete the square? This is really simple. You just need to know your square roots, your multiplication table, and you'll be able to answer this easily because not all quadratic equation is factorable. So let's use this. First, you need to know what the perfect square trinomials are. These are some examples of quadratic equations that's considered to be a perfect square trinomial. X squared plus 6x plus 9, x squared minus 10x plus 25, x squared plus 12x plus 36. Now the question is, why is it a PST? Or what is so special about this quadratic equations? It looks like the same quadratic equations we're looking at before, but why is this a PST? It's a hypothetical question because we're going to answer it right now. So, the reason why it's called a PST, it's because if we find the factors of 9, what are the factors of 9 that will give you 6 when you add them up? Number 2, x squared minus 10x plus 25. What factors of 25 can you think of that gives you negative 10 when you add them up?
5.
Just 5? 5 times 5 is positive 25, but 5 plus 5 is not negative 10.
Negative and negative.
Negative and negative. What about this last one?
6 and 6.
Positive or negative?
Both positive.
Both positive. And if we factor it out, this will turn into x plus 3, x plus 3. Can we simplify this further? Can we make the factored form a little bit smaller? Yes. We can change it into this, right? So, they are a special case of quadratics because they fall under a perfect square trinomial. Why? Because their factors are squares. Another vocab. When we talk about squares in algebra, it's not just the shape of a square. What is a square in algebra? Give me an example of a square in algebra. I'll give you one.
6.
9, because 3 times 3 is 9. Give me another one.
6 times 6.
So what is a square?
36.
36 is a square because 6 times 6 is 36. Give me another one. That is not in this example. Give me one.
16.
16 because it's 4 and 4. Give me another one.
49.
49 because it's 7 and 7. Give me another one.
64.
64, 8 and 8. So you got the idea now? Okay, so those are the squares. Not like the shape of a square. And we're going to look for squares. That's why this method is completing the square technique. So if you've heard about completing the square, it's not about completing and drawing a square. It's about finding the squares that would make up for that quadratic equation. Okay, now, this is a formula that we're going to be using to find the constant term. To find the constant term in our equation given the middle term. So if we're going to go backwards to find the constant term, you'll take half of the middle term and you square it. That is the formula for creating a perfect square trinomial. Are you understanding my language? I'm talking in English still, right? I'm not talking in Chinese.
No.
No, but do you understand me?
Yeah.
That the constant term is equal to half of the square of the middle term. I don't understand. Maybe you can talk in Chinese so you can understand it better. All right. To find the constant term or the last term, you take half of the middle term and you square it. Okay, mental math. Don't use your pen and paper. What's half of 6?
3.
Square it.
9.
9. Square means 3 times 3. Half of 10. 5. 5 times 5? That's how you find the constant term. And why am I doing this? I'm like, are you crazy? It's already there. Why do we need to look for it? It's already there. Because sometimes it's not there. Like this. Give me the constant term so I can produce my PST. What is the last term for this problem? It's going to be...
100.
Good job! Why is it 100?
Half of 20.
Half of 20 is 10, and square of 10 is 100. Yes! And if we convert this into a perfect square trinomial, it will look like this. Got it? Good. Can you change this into a square of binomial? Do it on your paper. Try it.
That's what I said.
Is that what you said? What did you say?
I said 16.
Oh, so you're wrong. You're right. It's 4. Got it? Oh, okay. Yeah, for a second I was like, oh yeah. I'll edit this. But yes, it's going to be 4. What about the last one?
Oh no.
Oh no. Why is it an oh no?
It's got half to 2.5.
Because it's a decimal? Because it's a fraction? Alright. Half of 5 is 5 over 2, right? Technically, it's 5 over 2. And you square it. And when we square it, we can distribute the exponent to the numerator and the denominator, right? It's a valid math move. What is 5 squared?
25.
What is 2 squared?
4.
So everything can be solved. Alright? It may be a little bit complex because it's an odd number, but at least you can still construct your perfect square trinomial. So if we convert this into a binomial, what will be my binomial? X plus what?
25 over 4.
Is it 25 over 4 or 5 over 2?
5 over 2.
Oh, power of 2. See twice.
And these are your binomials, and this is what we're going to be looking for in our solution. Okay. Now that you know how to complete the square, this is what we just did. Completing the square so we can have a perfect square trinomial. Easy? Easy? A little bit difficult, but at least you know why it's 25 over 4, right? So now, let's complete the square. Because we haven't solved the quadratic yet. We're just completing the square. Now how are we going to use this scale to complete the square? Okay, I'll show you. So just pay attention how I will use all the skills I just taught you to solve for x. So to complete the square, the first thing that you need to do is to get rid of the constant. And then after that, you're going to start completing the square by adding the constant here and the constant there that will complete the square. And what is the constant I'm looking for? It's half of 8 and you square it. What's half of 8?
4.
What's 4 squared?
16.
And now you have a perfect square trinomial. And what is so special about a perfect square trinomial? Because now we can modify this into factors of, what's the first factor here? What factors of 16 that gives you 8 when you add them up?
4.
4. Right? Can we simplify this into a single binomial? And now, from this equation, now we have a factored form with the PST in our equation. Let's solve for x. What's the first move? Which one are you going to get rid of so that x will be by itself?
Four.
So you have to
Negative.
get all the
Or times
square root.
It's the square that you need to get rid of. Mm-hmm. Now, is x by itself? You need to subtract 4. So, how are we going to simplify plus or minus 36 minus 4? We'll go split it into two solutions. That's the reason why you have plus or minus 4. So that means you will have negative 4 plus plus square root of 36. And you have negative 4 minus square root of 36. And what is the square root of 36?
6, or yeah, 6.
And we have two answers. What's negative 4 plus 6?
2.
And what is negative 4 minus 6?
10, negative 10.
We have two answers. And we did this by completing the square. I know it's a little bit complex. And again, I have my lesson on completing the square. So just click that little button right here and I have videos that will show you some examples on how we can complete the square. Alright, so that's how we complete the square. Now let's see if you can do this on your own. I know it's a challenge, but challenge yourself. Okay. So what is the first solution?
2,
And what is the second solution?
negative 4.
By completing the square. Okay, do that. Because you cannot take the square root of 32 unless we have a calculator. Alright? So this is how we complete a square. How about this? How are we going to complete a square with an example like this? We cannot separate it first because to be able to complete the square, the the quadratic term needs to be equal to 1. And in this case, it's not equal to 1. So how are we going to modify the function so that it will equal to 1, or the quadratic term will be 1? Yes, you will divide negative 3 on both sides. So this is negative 3 divided by negative 3 divided by negative 3. And whatever you do on the first side, you need to do it on this side as well. So by simplifying it, our new quadratic equation is x squared. What's the middle term?
Plus 2x.
Is it plus 2x or minus 2x?
Minus 2x.
And what is the last term?
Plus 4.
Plus 4 or minus 4?
Minus 4.
0 divided by negative 3?
0, negative 3.
Or 0. Now, can we use the perfect completing the square technique now?
Yeah.
Okay, solve it. Square root of 5. And we're done. Because we cannot take the square root of 5 manually unless we have a calculator. And if we have a calculator, our answer will be in decimal form. Okay? Can we use the completing the square technique for this one, by the way? After you simplify it. But can you simplify it? If you simplify it, what will happen if we divide everything by 3?
You get fraction.
you'll get fractions. And when we do fractions, it gets more complicated, right? We can still solve it using a fraction, but see how this will look like if we do it using a fraction. You don't need to solve it, but I will. A little bit. The sum of -5/3 plus 16/36. Which is crazy, right? I'm not gonna finish this. Because, let's erase this. We can use the last method. Oh my goodness. Quadratic formula. This is the last method that we can use in solving for x. Have you heard about the quadratic formula? Have you used it before?
Yeah.
Yes. Do you remember what the quadratic formula is? X equals -b plus or minus square root b squared minus 4ac all over 2a. Yes. Unfortunately, you need to memorize your quadratic formula. So if your quadratic is not factorable, if your quadratic equation is too much work for completing the square technique, use the quadratic formula, because the quadratic formula is the most powerful method in solving for a quadratic equation, because the quadratic formula can solve any type of quadratics, may it be factorable or non-factorable quadratic equation. Yes, this is the quadratic formula, and again, this is powerful because no matter what your quadratic equation looks like, if you use this, you will always find your answer. Now, why did I not use this in the first place and get rid of the factoring, completing the square? Because those are limited, it has limited powers because it can only solve certain quadratic equation, unlike this. The reason is because it's too much work. Alright, so let's solve the first one. So let's say we have 2x squared plus 3x minus 7 equal to 0, and we need to solve it using the quadratic formula. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And how did I memorize it really fast? It's because I've been doing this for over 15 years now. And the more you use math, the better you become at it. And I've memorized it because I've been using it all the way through. Okay, now, how do we use the quadratic formula? We need to identify what A is, what B is, and what C is. What is A, B, and C in this quadratic equation? What is A?
A is
2x.
Not 2x, but just 2.
2.
Just the coefficient of your equation. What about B?
3.
And what about C?
-7.
-7. Don't forget the signs because the signs of those A, B's, and C's are important. Now that we have our A, B's, and C, we're going to plug it into the formula. And this is the formula. So now we will replace it with the values. So we'll have
-3.
-b plus or minus the square root of b squared minus 4ac all over 2a. And then we will solve it. What's negative times 3?
-3.
What is 3 squared?
9.
What is -4 times 2, -7? Now, without even answering it, is the answer for -4 times 2, -7 a positive number or a negative number?
Negative.
Positive because there's 2 negatives.
It's positive because there's 2 negative. That's one technique that you can use in a quadratic formula. If you're seeing 2 negatives, you know it's going to be positive. Because that's a common error that most students do. They put minus right away. So 2 negatives, you know it's positive, and then multiply it regularly. 4 times 2?
8.
8 times 7?
56.
56. All over 4. And now the formula is becoming smaller and smaller and smaller, right? So let's continue. Okay. Now let's simplify this. What is 9 plus 56? 65?
65. Right?
So are we right the first time?
Yes.
All over 4. Now,
Over 4.
is 65 a perfect square?
No.
No. So if it's not a perfect square,
That's the answer.
you can have it like this. So that is your final answer. As long as the square roots are not perfect square. Another version of your answer could look something like this. So that you can show that there are two x's explicitly. You have -3 plus square root of 65 all over 4 and -3 minus square root of 65 all over 4. That's another way of representing your answer for the plus and minus symbol. Okay, let's see if we did it right. We use the quadratic formula. We have this A, B, and C. Quadratic formula. We have the substitution. And we have 65. We did it right. And that is the factors that we are looking for. Or -3 plus square root of 65 all over 4. Or -3 minus square root of 65 all over 4. So the quadratic formula will always work in any quadratic equation, no matter if it's factorable or non-factorable. So if you think you cannot factor, just use the quadratic formula because it will always give you the answer. So, on your own, can you please solve this using the quadratic formula? 3 over 4, right?
Yeah. Oh yeah, sorry.
Alright, 3 over 4.
Yeah, negative.
It is still negative because the top is negative and the bottom is positive, so it is negative. So this is how we use the quadratic formula for problem number 2. And again, always write your A, B's, and C's. So we have A, 8, B, 2, C is -13. We need to know the formula. And then when you have the formula, make sure to plug in the formula correctly, or the numbers in the formula correctly. So we have this, and then simplify it. You're seeing two negatives, so you know you will end up adding when you simplify the square roots. So we'll have -2 plus or minus 4 minus 96, which is positive 96, which gives you 100. And now that you have 100, you can further simplify it because you know that this will turn into -2 plus or minus 10 all over 16. And you'll have two answers, which is -2 plus 10 all over 16 and -2 minus 10 all over 16. And then you simplify the fractions, which we computed. And what is the first fraction? 1/2?
1/2.
And 3/4.
-3/4.
-3/4. Now, for the last method, we're going to be using technology. We're going to be using a graphing calculator, which I know you don't have right now, but I know you have your phone. So on your phone, can you please download Desmos? Go to your app store. This is a free app. Go to your Desmos, download it, and we are going to use it. How are we going to use Desmos? Because I want you to solve this. Can you please copy these quadratic equations in your paper? Notice that we have quadratic equations of any form. 4x squared minus x plus 9 equal to 0. Negative x plus 9 minus x squared equal to 0. 3x minus 4x squared equal to -8. And 21 minus 7x equal to 4x squared. All of them are quadratic equations because the highest exponent of your equation is equal to 2. Even though some of them are equal to 0 and some of them are equal to something else. Still, they are considered quadratic equation, and if it's a quadratic equation, we can solve it using any method. Factoring, quadratic formula, or completing the square technique. However, I want you to see how technology can help you answer this problem. Are you ready? Can you please give me the other examples that we have?
Negative x plus 9
Negative x
plus 9
plus 9
minus x squared
minus x squared
equals 0.
equal to 0. Now, what do you see about your graph? It's a parabola opening downwards, right? And if you're going to find the solution of this graph, just use your cursor and put it right here. And you will see two solutions. Two ordered pairs. Negative 2. So in this one, x is equal to negative 2.541. And the other one is going to be 3.541. That's how you find your solution using your Desmos. Hello everyone, this is Dr. Esperanza, and if you happen to like my video, please like, share, and hit that notification button and subscribe to my channel. Thank you.